In this video, we'll talk about atomic solids. There are three types of solids: atomic, molecular, and ionic. We will focus on atomic solids in this video. There are three subtypes of atomic solids: non-bonding, network covalent, and metallic. There's no bond between atoms in this non-bonding atomic solids. There are covalent bonds in the network covalent atomic solids. There are metallic bonds in the metallic atomic solids, or simply put, metal. Let's look at a few examples. First, non-bonding. Solid argon and solid xenon are non-bonding atomic solids. There is only dispersion between those noble gas atoms, and the dispersion is small. Therefore, the melting point of those non-bonding atomic solids is very low. For example, the melting point of argon is negative 189 degrees Celsius. Xenon is slightly larger than argon in size, and therefore we expect xenon, solid xenon, to have a slightly higher melting point than argon. Now, network covalent. We'll focus on this covalent here. There are covalent bonds between neighboring atoms. For example, in diamond, there's carbon-carbon single bond between two neighboring carbon atoms. Graphite, actually the bond between two carbon atoms, two neighboring carbon atoms, is stronger than a single bond, but weaker than a double bond. We will look at the structures of these two a bit later. Quartz. The formula is silicon dioxide, but really each silicon is bonded to 4 oxygen atoms in this structure. So I want to show you this here. So each silicon is bonded to 4 oxygen atoms. Let's look at this one. But I'm showing you just the partial picture of this silicon dioxide. Okay, this one is really good. This one is bonded to 1, 2, 3, 4. Each silicon is bonded to 4 oxygen atoms, and each oxygen is bonded to only 2 silicon atoms. All right, again, those are covalent bonds. Covalent bonds are pretty strong. For example, in diamond, the carbon-carbon single bond has a bond strength of greater than 400 kilojoule per mole. In graphite, the carbon-carbon bond strength is even higher than 400. And also, between silicon and oxygen, there is strong covalent bonds. Therefore, this kind of materials are really hard, and they have a very high melting point. It's very hard to break those bonds. Therefore, the melting points are between 3,000 and 4,000 degrees Celsius typically. I think diamond has a melting point roughly 4,000, the graphite roughly 3,600. Well, quartz is a bit lower. I think quartz is has a melting point slightly lower than 2,000, but anyway, we'll just put a wider range here. The last type, metallic, it's just metals: gold, silver, copper, iron, titanium. The bond between those metallic atoms is called a metallic bond. A metallic bond is weaker than covalent bond, and that's why the melting point of metals is usually lower than the melting point of those network covalent solids. So look at the range here, right? And also there's another fact that metals are typically softer than those network covalent bonds. Diamond is the hardest material, or one of the hardest material with the highest hardness. Gold, on contrary, is fairly soft. Quartz is very hard as well, and silver is pretty soft compared to quartz or diamond. So let me show you the structure of a few atomic solids. This is solid argon, and we're showing you this face-centered unit cell of argon here. Again, between two argon atoms, there's only dispersion, and the dispersion is small. Therefore, the melting point of argon is very low. This is gold. Again, we have metallic bonds between gold atoms, and the metallic bonds are weaker than covalent bonds. Therefore, the melting point of metals are lower than the melting point of those network covalent solids. Now let's look at graphite and diamond. So all those are carbon atoms connected by bonds. Those are not single or double bond. Those bonds are between a single and a double bond, so it's stronger than a single bond. And pay attention to this 1, 2, 3, 4, 5 layers. Those are called graphene sheets. So in this picture, you're looking at 5 graphene sheets. And over here, this is diamond. Each carbon is bonded to 4 other carbon atoms, and those are single bonds with a bond strength of more than 400 kilojoule per mole. And because to melt diamond, you need to break all those very strong covalent bonds. And that's why diamond has a very high melting point. And diamond is very hard because, again, if you want to break a diamond apart, you need to break a lot of those carbon-carbon bonds. That's very hard. On the contrary, graphite is softer. This is because to break graphite apart, somehow you don't need to break any chemical bonds. You can break, this graphite this way. You can break these 2 layers from the bottom 3 layers. And between these 2 layers, there's dispersion. Dispersion is weaker than chemical bonds, so it's a lot easier to break graphite apart. That's why graphite is a lot softer than diamond. However, the melting point of graphite is high, because if you really want to melt a piece of graphite completely, again, you need to break those carbon-carbon bonds. So graphite has a really, really high melting point. Over here, this is silicon dioxide. The blue spheres are silicon atoms. The red spheres are oxygen atoms. And you can see every single silicon is bonded to 4 other atoms. Usually, silicon is bonded to 4 oxygen atoms unless there's a defect. And each oxygen is bonded to 2 silicon atoms. Again, this is because oxygen has 6 valence electrons. By forming 2 covalent single bonds, each oxygen atom can be surrounded by 8 valence electrons in total. So over here, you can see all atoms are connected by covalent bonds. Again, that make the melting point of silicon oxide or quartz with a really high melting point. And this material is very hard. It's difficult to break a piece of quartz. Now let's look at some practice problems. Let's rank the melting point of the following atomic solids: argon, diamond, and copper. Okay, diamond has the highest melting point because, again, to melt diamond, we need to break many carbon-carbon single bonds. Those are very strong bonds with a bond strength of more than 400 kilojoule per mole. What about the metallic bond in copper? It's roughly 100 kilojoule per mole or 200 kilojoule per mole. It's weaker, therefore it's easier to melt copper. I think the melting point of copper is roughly 1000 degrees Celsius. Argon, we talked about it. There's only dispersion between argon atoms. So let's look at the second question. Let's rank the hardness of the following atomic solids. Well, the same 1, 2, 3 solids. And then similarly, diamond has the highest hardness, followed by copper, followed by argon. Let's look at the answers. The melting point of diamond is roughly 4,000, copper 1,000, argon negative 200-ish. All right, that's it.